start. We drew this this up last week. There was a slight issue with the geometry showing up in that dark blue color. And so one of the first things we want to do is, since my configuration file is staying put, and notice that from the last selection, we have some dark blue, that was the object, the cyan that I changed over to, the magenta, which was the result of the mirror, and the red, which was the selection. So one of the things you can do is start to kind of read into these color codes, kind of what's happening. And then find the little icon up underneath the attributes that says clear colors so that we can get back to, all right, well, it's not perfect, but we're getting a little closer. So on that end, I'm going to go back to the file, go back into the configuration, find the colors, and of course it was the very last one was the wireframe geometry right in front of me, couldn't see it. And I'm going to switch that one over to cyan, and yes. And so anything that we draw from here on out should be in that lighter blue, at least have some contrast. All right, so that doesn't help me with the existing geometry. So I'm going to do the window pick. So just left mouse button, click and click. Everything highlights in yellow as a selection set. And then our colors. So wireframe color, it defaulted to whatever I changed it to, but now I need to basically set everything. All right, so that should be a little more visible for us. All right. So we talked a little bit about selection for stock. One of the things I'm going to do at the end, I'll warn you up front that I jump around. That's the way I program. There's nothing linear. If I think of something, I address it. All right, so we're going to face, we're going to contour the perimeter, we're going to pocket through the center, we're going to decide if we're going to load up drill bits, or if we're just going to take the 1/2-inch end mill and plunge it through. All right, maybe it takes 2 or 3 minutes on some operations. In that case, I can justify loading up a second tool, 3/4 inch tool, and probably a pilot drill. All right, going into aluminum, we're going to have to discuss those tool choices. There are times where in aluminum, I'll just take the 3-flute end mill and do a circular helical bore and blow that center out, run a contour, and maybe I've sacrificed 30 or 40 seconds apart. We're not, if we're not in the mindset of we're making thousands of these, I may forego the tool change and have one extra operation with the existing tool. All right, so let's just say we're making a handful of these. So maybe somewhere between 1 and 100. And our stock is going to be enough oversized that we're going to be able to run around the outside of the part. And let's take a look at the print again real quick. So we have 1 inch of depth. We're going to say 1 1/4 inch of material, and we're holding on somewhere between 1/8 and 3/16 in the vise. So our parallels are pretty tall. We're not holding on to a lot of material, but this isn't going to be an overly aggressive machining operations. My recommendation is to always start at medium to low feeds and speeds. When you get it out to the machine and you can observe and react to the cutting conditions, then you can make it go a little faster. Then you can get them a little more aggressive. Get the parts being made and turned over to your operator, to your setup, and then come back and start to fine tune and resolve issues as they occur. All right, so said that I'm not fond of the origin at the center. The mold making strategy of as far as I know is to put everything at the center, and then regardless of the shape of the material, we're aligning our geometry center of that part, and then everything kind of fits into it regardless of how square our mold base came in. All right, this isn't a mold, so I can make the case of I want to go what's convenient, basically touching off on one of the corners. And if I put a work stop and the hard jaw of the vise, and again the ergonomics of it just say that I'm going to hold the vise handle in my left hand. I'm going to pick up the part with my right hand. I'm going to slide it up against the work stop. I'm going to close the vise. I'm going to take the handle off, close the doors, and hit cycle start. And from there, I'm going to watch whatever happens. So that being the case, I want to move the origin that we drew around, which was convenient. All of our dimensions came from that point. I want to move it up to the corner. So since we have the 1.25 by 1.25, we'll go ahead and do that first. All right, so XYZ coordinates, quadrant 1, positive, positive, quadrant 2, X negative, I should say X positive, Y positive, quadrant 2, X negative, Y positive, quadrant 3, X negative, Y negative, quadrant 4, X positive, Y negative. All right, and if no other reason, that fixed jaw provides a stationary datum. My work stop on the left or the right. I mean, so realistically, unless we turn the vise around or you've got one of those double acting vices, and that's a whole nother conversation, by the way. We're going to pick what is convenient, and so I'm just going to do the window pick, click, and click. And so dragging around the part, we're going to transform. And I can do this one of two ways. If I had a corner up here, I could pick the corner and go from corner to the origin. Since I don't, when I pick the translate, we have the geometry. I do like to pre-select. Now, if I'm thinking in terms of I am going to pick this object up and move it, then I'm going to grab everything that needs to be moved. All right, so the method is to move. The instances is 1. We've already got the selection. All right, and then based on our current positions, the delta should be 1.25 in X and minus 1.25, maybe not a 10, minus 1.25 in Y. All right, so that puts the corner right on the origin. And the magenta is not great, but we'll get it cleared up here in a second. So I'm not moving anything else. All right, so the first checkbox is OK, and then do it again. I want to go right into another move for whatever reason. The second check mark is to hit OK and exit the command, and then cancel or exit it without saving the result. All right, and so with the magenta, I'm going to go back. Well, let's see if I got it on the right mouse button. So there's the clear colors. The attributes come over, and we'll go ahead and clear the colors so that we're back into the magenta. And then on the scroll wheel, it's kind of in relation to the screen. So it takes a little bit, especially since I'm used to SolidWorks. SolidWorks zooms around the cursor. Several programs will zoom around on the screen. So that's one way to kind of zoom in. So if you see me flicking the scroll wheel back and forth, I'm doing the lazy way of zooming. Also, Alt-1 is our top plane. Alt-2 goes to the front. Alt-3 to the back. 4 to the bottom. 5 right. 6 left, 7 isometric. All right, isometric is going to be handy when we go to preview the toolpaths, when we start looking at depths and double checking our numbers, because it's easy to make mistakes and leave positives and not get negatives, and if you miss that sign, then we're going to see the toolpath floating around above the part. All right, so the two that you really need to remember are Alt-1 and Alt-7. So that kind of centers it on the screen. And at this point, we're saying that when we go out to the machine, we're going to measure the stock, and if I move in 10 thousandths in Y, go into my control, touch off in X and Y with the edge finder, tell it to take an additional 10 thousandths in Y into the material, take an additional 10 thousandths or so into X, that we're going to be able to run around the outside of this part. So we're going to talk about the difference between a roughing and a finishing pass, because they're basically the same the same operation. It's just, are we going to step and repeat, leave compensation? And what happens when I've cut all of this stock and most of it is, say, 60 thousandths over in X, and the saw cut's pretty rough and angled and whatever. And then my material thickness is varying between 15 and 20 thousandths oversized. So I'm at the bare minimum of that 10 thousandths that I want to take for cleanup. Right, so we're juggling those numbers at the control so that if I have to, if I see a trend that material is not cleaning up all the way around or on one side, at the control we can move it back a couple thousandths, try and bring it back. Or we're over at the sanding block and the Scotch-Brite making it look pretty and it's still within tolerance, get it out of here. No, nobody ever does that. All right, so that gives you kind of the basis. We're always starting with that, and whether it's a personal 30-second conversation or you sit down and go, we're making thousands of these. I really need 3 blocks coming across so that I can hold 3 of these in the vise at one time, and we can make 3, and then I'll write into my operating MOT, the machine operations and tooling, that the second step after this is, well, first is that we saw, second is that we run this first op, third is somebody gets to stand at the bandsaw and separate them, and then cut them into 3 pieces. Then we flip them over and machine the backside. And so, we got to think about some of those strategies. If we're making 10, then I can stand at the saw. If I'm paying the material supplier 50 cents to $1 a cut, maybe I tell him to make 3 less cuts or 2 less cuts per 3 parts, and we go ahead and bulk up the machining. So juggling that information, and whether, like I said, whether you're having that conversation with yourself or you're sitting down with the machine shop manager, the purchasing manager, and saying, what do we want to do? Be prepared with that conversation. All right. So over into the machine tab, we have our choice of mill. And so if we go to the default, that's going to just be a generic mill. So if we go into manage the list, then I was expecting to see a few more than that. Let's see if they installed somewhere. That's the operation. Okay, I guess I should have checked that out. We're going to do the we're going to need to do the default then. So normally I would, since we have the Haas machines out in the shop and would be looking at going to run on those, we'll either find that post or identify it on the computer. So we'll go ahead with the mill default. All right, and then that should, well, I didn't get the toolpaths, so that did not take, so let's just go with the default. All right, that was what I was looking for. So under that pull down list is, if I see the default, I see the Haas, maybe we have another couple machines in there that we can pick from for posts, then we would select the machine that we're going to run on. And as soon as I see that machine group and the properties and the toolpath group, I'm where I need to be to start the program. We've generated the geometry, or later on we've imported the geometry, and whether it's a 2D drawing or a Parasolid solid model, we have something that we can machine to. Yes?
Other than choosing mill, or when you choose mill or lathe or whatever, other than selecting a different post, is there anything else that you can customize about that machine?
Not so much. There are some things in the that will go back and under the control definition and the machine definition. Okay. There is a lot of information that we can set defaults, that I want this information to show up in the header, I want this, and I don't want. What I typically do is I'm going to watch as I go through the process of programming, and if I'm changing things all of the time, every time, that's something I'm going to want to try and identify as a default that I can set in the machine definition and kind of jump over that step. Okay. So machine group basically says that I can have a mill if for some reason that this was a round part and we were going to also put this on a lathe, I could have a second machine group that would manage the lathe. I could have a third machine group that would come back and wire EDM. So the question is, do I need 3 separate files? If this gets complicated enough and I build this tree out of a million lines long or a million operations long, I may want to break it up into separate files. All right, but I'm going to at least attempt to keep all of the documentation in one. All right, so by hitting the pluses and minuses, we can collapse. And then when you hit the plus next to properties, these are the properties for the mill default. And let's see if I double click. So I just double clicked on the files. These are the types of things that go into the header. So the group name, toolpath directory, group comment if you want to. And at the bottom, the output comments in C file, the operation comments, machine name, group comments. You can have all of that written into the header of your program. Most of the time, the operation comments are fine. So things like the tools and the tool descriptions. Everything in between is the toolpath. So this is the post. On occasion, I've selected the wrong post or I need to change machines. And so I can edit and replace and go back and forth between the control and pick those up, make adjustments to them. Standard tool library location, operation library, operation defaults. We'll get into those later, and setting up a tool library. So if you have the side mount tool changers where tools pretty much go in and they come out every 2 to 3 months, if just for inspection and cleaning or as tools break or wear. So in that case, we could have a tool crib, and position 1 is always my 1/2 inch end mill, and position 2 always my 3/8 inch end mill, and down to 1/8 of an inch. If we're doing large stuff, it may start at 3/4, and then we jump by 1/4 inch increments to cover the widest range of machine operations. Say tools 1 through 10 live in the side mount, and then after that, we're loading tap drills and drills and reams and taps and whatever other custom tools we need for that operation. All right, so that would be the purpose of a tool library or a tool crib. All right, oh, and I clicked out of that too soon, so stay in there. Tool settings then is the default program number is going to be program 1, so since I'm changing that, that would be something that I would want to go in and write as if I can change it, right as the default. The toolpath configurations, assign the numbers sequentially, because when you pull a 1/2 inch end mill out of the standard default Mastercam tool library, it could be number 239. Well, I'm not going to load 239s, and I really don't want to tell my control that it's 239. So if it's the first tool that I pick, it's number 1. If it's number 1 in my library, it's number 1. And I'm going to load them in that order. Also, warn of duplicate tool numbers. So if I'm typing things in manually, I want to make sure that those are being tied correctly to the station number. We have a choice on the tool step, pec, and colon as we develop and go further into the tool library. We may set parameters specific to that tool, and then we can override and say, it is carrying the data with it, so use the tool step, pec, and coolant. And then I don't usually search by tool number, so I'm not too worried about that one. Feed calculations from the tool. Again, if we've built that information into the library, if it's doing pulling from that database, we can pull feeds and speeds from different locations. So most of the time it's from tool and just what you get used to also. Sequence numbers 1 by 1. All right, or maybe start at 1 and go by 5s. All right, in the old days when we wrote programs, we went by 5 so that we could leave room in between if we if we missed. All right, so then the material, let's go ahead and if we edit, then these are the base surface feet, the calculations for the different operations. And then somewhere in here, we're looking at percentages. Say one of them has the different materials. So kind of if we go with the program, this is the table that it's pulling from for that material. If I just want to tie the material, then aluminum inch and the material list, we're going to come back to the mill library. And then there is my aluminum 6061. And when I hit OK, it's going to update it. And then if I go back and edit it, it's not much different than the 2024, which should be a little gummier, but that gives us, again, our base starting point. All right, so when we dig into the machine and the control configurations, these are things that I'm going to want to try and identify and set as the default so that I don't have to change them every time. All right, and kind of the problem with setting defaults is I do it once a year or once every 5 years, 3 years, somewhere in there. So I have to go relearn the process every time I do it and push a bunch of buttons, get aggravated with it and frustrated, and then, oh, there it is. All right, so stock setup. Not the most intuitive of stock setups, but once you kind of get into the process, it will work. And also, as we accumulate geometry and have more geometry to select from, we can use the pick options. So the first couple of programs, we're going to do this manually so that you get a feel for how this works. All right, so if we had left the part at the origin and set our 000 for the program at the center of the part, then the stock origin would have remained 000. All right, since I didn't do that, then X becomes 1.25, Y becomes minus 1.25, and then my X and Y positions are 2.5 and 2.5. All right, so the shift, like on some of the routers, where if you see a negative number, you're going into the vacuum or into the vacuum table or going to break vacuum. So negative, usually we're going to program positive because we want to identify those negative numbers as potentially being very bad. All right, so in that case, I would pick the stock origin up and make a shift so that it, in conjunction with the stock and the origin, it raises it, or actually it lowers it to the table being our 0, and all of the operations are positive. So that takes a little bit of playing with. So I do want to display, and I'm going to leave it in wireframe, and when I hit OK, hopefully we see the, all right, so middle mouse button, nope. Where did it go? Oh, maybe I double clicked.
You didn't give it a thickness.
Oh, yeah, thank you. So we said we're going to go with a 1 1/4 stock. I was talking about it and not entering it. Here we go. All right, so the dark red lines are not going to be very easy to see, but what it's saying is the stock is encompassing the part. All right, so I can go back to that Alt-1. All right, so what happens if I don't set the stock is that when I go to post this code, it's going to ask me every time to enter those 3 values. What is the stock size? Or at least last time I didn't enter the values, that was what it did, was it asked every time. So it's just easier to set up the stock and have it know where the origin is at in relation to our stock so that we can move on with it. Okay, so the Toolpath Group, one of the things I recommend is that you kind of right-click at the different levels. So if we wanted to create a new group, we can create a new machine group, a new Toolpath group. Be careful, be very careful with delete, because it is typically a one-way. There is no undo, redo, or very rarely there is an undo, redo type deal. and then deleting all of your empty if there's no operation or no chain associated to it. With the errors, it shows you undelete, but don't count on that. Just make sure that what you're deleting, you actually want it to go away. Let's see, some sort operations. And then under the pretty much the properties, then we can do the same thing. We can have subgroups. And most of the time, a toolpath group, you know, just if something is getting complicated enough and we want to run partway through, then the toolpath group gives me an option to organize or have like an intermediate folder. All right, and then the red arrow, the insertion arrow, where that arrow is located in the operations, that is where a new operation will be input. All right, so if I have 3 operations and I want to put a new operation between 1 and 2, I'm going to drag that arrow up, and then when I right click and say Toolpaths and go to the selection, it will, whatever I pick goes between 1 and 2. All right, across the top on the toolpaths, then you have contour, drill, dynamic, face. Anytime you see the expand gallery, that is everything. All right, so if you are only looking at a portion or you want to scroll down, granted there's a lot more information in there than we really need at this point, but you can do that expand, and then in the 3D we're not really concerned with multi-axis, not yet. The stock display, tool manager, when we go to select tools, we're not going to do that right away. The probing, so if you have the Renishaw probes and you want to inspect mid process or anything, the probing goes through and is capable of switching over to that tool probe and or the to that probe, and then identifying the part or the tolerances on the part. Let's see, toolpath transformations. Probably get into that a little later. 5 axes, trims, nestings. All right, so the main one is going to be under 2D, and because I'm a heavy right mouse button user, I'm probably going to stay with, there's the operation, there's the toolpaths, there's the contour. Right, and it's just whichever habit you develop of coming up to the ribbon bar or going into the right mouse button context menu. All right, so we have our first operation is to establish our Z face. Occasionally stock will be right on size and it will have a nice surface finish, but 99% of the time we're going to make a facing operation to get rid of the gouges, the butter coat, the score marks, the manufacturer ink on the surface, and any you know, even adhesives and stuff gets kind of included into that. So when I pick the face, it's going to show me the pop-ups. Let me pull this over so that we can get this. Oh, nice graphics. Select OK to use define stock or select chain 1. All right, if there was only a portion of this, maybe I wanted to, when we get to let's see, which one of the parts has a step or portion. If I just wanted to face in one area, so I know that I'm going to come back and pocket. If this was say a hard material, and I'm worried about tools degrading, I may only face and have it ignore this this center bore as an island, and I would go through and I would pick my operations, let the tool go everywhere but in that island, and then the roughing tool would actually take off that surface as well when it blew out the center. So I could go back and select chain 1. The defined stock that we just set, that's going to be fine. So I don't have to do anything except hit the check mark, and it's going to read the geometry that we selected. All right, so in this case, I always kind of look over on this first toolpath type, and I'm observing what the chain geometry is listed at. On a facing operation, it's going to be 0. It's looking at the stock that we just defined and saying, that's good enough. I'll be able to calculate from there. We need a tool. And so it selected a tool diameter, corner radius of 0, 2-inch face mill. We're going to minimize tools. And if you are working out of the beginner tutorial manual, they'll probably have you stay with the 2-inch. I don't particularly care which one you follow. If you want to follow my videos, if you're using the Mastercam book, then and follow that. I just want to see toolpaths, and I want to see that it's realistic that what you're telling it to do is going to make parts. We're not going to get into this tool over that tool, mostly, especially with aluminum. Any 2-flute or 3-flute end mill, for as long as it has the length of cut, is going to make this part. So looking at that, we have nothing over here in our list, and so this is just the default for that operation. When I go into the library tool, then we're going to see all of the tools starting with number 1, our number 1 center drill, and I would like to filter that out. And so on the tool list filter, let's select none. And in the none category, then we can go back and say, let me have all of the flat end mills. And so when I turn that one on, the filter is active, and I should be able to hit OK. Then all of those center drills are gone, and we're looking for a 1/2-inch flat end mill. So I missed it by, what, 51, number 290 instead of 239. All right, so I'm going to accept tool 290, and now it is added to the list. When it is added to the list, then the tool diameter is showing as the 0.5. It has tool number 1, length offset number 1, and diameter offset number 1. Most machines, the D values, the H values, and the T value are all going to be the same, because otherwise it says, hey, there's a mismatch. Are you sure you want to do this? Did you override it in the control to not be safe? All right. So feeds and speeds into the aluminum. If we go with the surface feet per minute, let's just try 800 surface feet per minute. Gives me 6112. All right, that's kind of a weird number. I may have a spindle that runs 6,000 RPM, 7,500 RPM. Well, okay, let's start at the lower end. I may have a spindle that runs 4,000 RPM, 6,000 RPM, 7,500, 10,000, 12,000, 15,000, 30,000. All right, that's all going to kind of be based still on the tool material and the diameter. So if I look at the manufacturer recommendations and it says that I can run at 1,000 surface feet per minute, then I type in the 1,000 and 7640. If I have a 7,500 RPM spindle, I can run it up to 7,500. All right, so I'm my preference. And I always say I'm not the Oprah Book Club that you have to go out and buy this tool because it works the best. What I pick, or what I look at, we've been using the AccuPro zirconium nitrided 3-flutes, right? And I can run that at 9,000 RPM at a fairly aggressive rate, somewhere between let's see what it looks like at let's go with the 2,000s. So 45 inches, okay, they're 61. All right, so when I typed in the 2,000s per flute, we'd have to look at the definition. That's probably a two flute, maybe a 3-flute. 61 inches a minute, that's pretty aggressive for a very start. All right, but depends on, again, are you doing the setup and are you the operator, or are you handing this off to somebody? All right, so the other thing would be that if I do run this at 9,000 RPM, I can put in the spindle value and it's telling me the surface feet per minute is up around 1,200. All right, so there again, if I'm running an uncoated carbide, and depending on tool geometry, I may not be able to make it to 9,000. All right, so we're always going to at the machine decide, is it chattering? Is it squawking? Is it happy making this part and ejecting a good chip, or is it loading up and giving me problems? All right, so that nice mid-range was 7,500, and the feed rate of about 40 inches a minute was what, 1,003/10. I'm okay with that as a starting point. Right. And then if we get out to the machine and it can run faster, we will. Yeah.
So may have already covered it when I had to take a phone call, but when you define your feet per tooth, is that when you have to update it in your tool library in terms of this is a 3?
Well, let's check. We didn't go back and check. His assumption is it's a 2 or a 3, and I'm pretty sure that, you know, from experience that one. Yeah.
It said it's a 4 group.
Did. Yeah, the definition coming out. Overall cutting length. All right, so when we get into, I just double clicked on the tool and my fingers did that automatically, so let me back out of it. So the tool in the tool list, double click. And if we could see the whole list, it should tell me what the flutes are. All right, so overall length, cutting length of 1 inch. Well, we're going to go a little bit past 1 inch, and a standard end mill, half-inch end mill is 1 1/4 inch in most manufacturers. Shoulder length, shoulder diameter, shank diameter. Is it a flat end mill? Does it have the corner radiuses, or does it have chamfer? Oh, let's see, wait a minute. Am I to that? There we go. Is it a square corner? Is it a chamfered corner? Or is it a hog nose, a rounded corner? And then the shank, is it reduced or is it neck down? All right, so you can get into a little more of the definition. And then we'll go next. There we go. Tool number 1, length offset, feed per tooth. These are going to be the defaults. And then, yes, there's the number of flutes. So let's go with a 3 flute. And we should see a little bit of adjustment there. And make sure I enter. And we'll go finish. All right, so since I changed the values, my 40, let's see. So let's go in. All right, so that reduced it down to 30. But somewhere in there between 2 and 1 and 2 thousandths per flute chip load, we're going to end up around 40 to 45 inches a minute. That's still pretty fast. All right, so I'll give you an example. The tooling plate that I prepped, I put on the table. I touched off the first part to the table and forgot to raise it up to my tool offset. And I said, that's making a strange sound. And about the time I looked down and hit the feed hold, it had moved about 8 inches, half-inch wide, 3/8 of an inch deep into my brand new tooling plate. So I always know which side of the tooling plate faces because I put the gouge there. All right, so 45 inches a minute is, don't blink, because it is still moving pretty good. Now we can be more aggressive. On a part that's 2.5 inches long, are we really ever getting to 45 inches a minute?
No.
It's debatable. Your acceleration, your decel rates, you know, you may see it on the control. It says it's doing 45, but realistically it's not. So if that's the case, then I'm better off staying at the lower and then making the adjustment as we go, as we see the results. All right, so all of this is just a juggling act. You're picking numbers based on the control, the rigidity of the machine, the material that you're using. It becomes certainly a lot more critical when you're into the stainless steels, into the tool steels, into the high tensile alloys and super alloys, where, you know, an inch a minute may be too much because you have to run it at low RPM, get it fully engaged. The tool does not like, you know, little light cuts. It wants to be hogging into that material and have the heat, or it's just going to degrade faster. All of those are variables that you will have to adjust for. I don't do too much with the holder. Notice the check mark, by the way. That says that we made changes there. And since I jumped, let's see if there's anything else. If you want to put the comment in for the half-inch end mill or what the operation is, you can put it into the comments. So we'll see what it looks like when we post if we need to put additional information. Going back to the holder, holders are handy in 4-axis and 5-axis where collision is a very high potential. All right, so if you've got the geometry, the interesting here is that we have to go down to, and I don't remember the designations. I know that we searched through and we found the Cat 40 with for a 1/2-inch tool. Okay, extended length, pretty close, but it's updating. It's giving you pretty good bit. You know, deciphering the numbers, not the most convenient. Let's see. So that was a 500. Well, let's just stay with the 500 then. All right, but I'm not going to pick a holder. We're not showing the holder in the simulation most of the time. If there's collision issues, it's usually going to be with clamps, and those are hard to predict. You know, if we're on the tooling plate or we're working around those geometries. All right, going into the cut parameters then, we're going to go one way. We're going to go zigzag or dynamic. So one way would be we have an older machine, and as it reverses direction, the backlash compensation isn't quite there, and we get a swirl one way, and then we get a little bit of separation, and we get a swirl the other way. And if I really want that fine surface, I'm going to load the table in the same direction, lift up, go back to the start, go one direction, lift up, and go back to the start. If the machine's reasonably tight and not concerned about the backlash, then we can zigzag. One pass would be that we have that 2-inch or 3-inch face mill, and it's just going to find the center line and go all the way across the part. And then dynamic is always a little interesting, depending on the shape of the tool. A lot of times, if I'm holding on, one of those vertical 3 draws, I have a round part. I don't really want to face. I'll use the dynamic for an odd shaped part. So let's just stay with the zigzag. We have a cross overlap. All right, so how much between the toolpath? So it's saying 25% or 1/8 of an inch. So it will step over 3/8 of an inch and then overlap the previous by 1/8 of an inch. The long overlap, 110%, so it's going to run off of the part before it turns around and comes back. Or in the case of the one way, it will run completely off the part before it lifts up, retracts, goes back to the start, and comes back across. Approach distance is 50%, so where does it come down? If we hear the little buzz of material as the tool's engaging into the part, we might want to increase that a little bit. But usually 50%, and 50% on the exit distance is going to be enough. So the issue here would be that we're right on the stock. If I have material that's a little bit oversized and we did that adjustment at the control, then this might need to be closer to 60, 70%. All right, 1/4 inch may not do it. So 300 on the exit, as long as it comes off the part, I'm okay with that. All right, so just maybe a little bit extra on the approach, especially if we cut the material long. Our saw is not the greatest; it's cutting a little angle, so I add 60 thousandths or 80 thousandths of material. Then when I do that adjustment at the work offset, I'm just allowing it to come down and do that face without touching the material first, potentially chipping teeth. All right, max step over 375, 75% of the tool. So that was kind of the math between the 1/8 inch and the 375. Those should add up to our diameter. Climb to start, even number of passes. Not necessarily. If for some reason you wanted it to, let's see if it went start, finish, even number of passes should end on this side. If you wanted it to end in a certain position or trying to get it to end in a certain position, we could try that one, but most of the time, no, don't worry about it. Angle, right now we're going to be running at 180 degrees back and forth across the part. If we changed it, well, okay, 0 degrees or 180 degrees. If we changed it to 90 or 270, it would just be the termination. Is it starting in the lower left and going up, or is it starting in the upper right and going down? No, I'm not sure. Okay, so right now our roughing angle starting over at the corner and going back and forth is going to be fine. So you kind of adjust that one, see what it gives you on the screen, and is it doing what you want it to do. If you have a part that is going to be an advantage running it at 45 degrees, then set it to 45 degrees. If we want to override the move between cuts, this is showing kind of an arc, which is a smooth transition. It doesn't have to kind of come to that stop, decelerate, and then change directions, decelerate and change directions. It just stays throughout the curve or throughout the arc in the feed rate. Stock to leave on floors, more than likely we're going to touch this tool off on the part and then subtract 10 thousandths, 5 thousandths, somewhere in there to perform the cleanup. So leaving 50 thousandths on the floor would raise the material back up. In this case, no, we don't need, whoops. Hit one too many buttons there. I zeroed that one out and then I hit escape, and so stock to leave on the floor is 0, so that will go to whatever depths. And then if we had a lot of material that we're removing, we would access the depth cuts, a depth cut of 0 and finish depth of 0. I'm just going to uncheck that. All right, so my check mark's probably in the process of saving it. I'm going to go ahead and apply those, and that gets rid of the check mark. And so as we're going along, we're just kind of double checking that anything that we've applied that we want to keep, in case I hit escape or tell it to do something, that it will retain those values. All right, so the retract plane is set at 0.25. Most of the time we will go to 1 inch. Initially, I'm going to have you stay with absolutes. Right? Incrementals say that we can adjust based on geometry selections. Let's just cover and say that everything is an absolute. All right, so we're 1 inch above the part. If I had 100 thousandths of material that I was wanting to take off, 200 thousandths just gives me a safety factor. All right, that I'm above the part. If we're only taking 10 thousandths, I really don't need to feed down from 200 to the cutting face, the top of the stock, to make that cut. And then the top of stock is 0 and the depth is 0 because we're doing a facing operation. It's just establishing that Z-plane and getting us our geometry. Now, if you wanted to include it, you could touch off and tell it that the depth is minus 10 thousandths, and then our depth of 1 inch would be minus 1 inch and 10 thousandths. I really don't like doing that much math. So it depends on your strategy. When we go to the control and I tell it that there's a wear value, or I tell it that work offset, I'm going to shift everything down at the control. I'm going to manage it at the control. Right? So it keeps the values clean in the program, and we make the adjustments at the control that we need to bring the stock in. Yes?
I had a question on the cut parameters concerning when you have roll cutter around corner. So is that what you do to adjust if you're doing, say, a tougher material? Because around that corner you're going to get a different angle of engagement if it's rolling in.
Yeah.
So is that how you manipulate that? Actually,
it didn't keep my zigzag. So when I kicked that out. All right. So if you want to go to the move, you have high-speed loops, the linear, and the rapid. So I think the default is that arc. If we go to, I was going to show the preview. Well, no, we're not getting the preview, so we're going to have to actually let it generate. So let's go ahead and kick those off for a second. And let's see, and the tool. Okay, the dirty operations. All right, having to shift. All right, so the one I jumped over, jumping into simulation. All right, so the sharp, and if we go to none, then the one that I jumped over is we have the selected operations. Right now we only have one operation. Select dirty operations. A dirty operation, and this is where I have to shift gears back into Mastercam, is that when you see that X, we made a change and it hasn't updated yet. And it won't update until we tell it to regenerate all selected operations or regenerate all dirty operations. So we can tell it everything or just certain items. So I regenerate. Now that doesn't look much different. So we really don't have any corners to roll around in here. So when we're doing the contour, this is maybe more of a contour path. You're going to see this same structure, a lot of the same parameters throughout the operations. Not all of them apply. So the move between cuts, let's go from linear to high speed, and then we'll regenerate. So there's the arc, and then the rapid, and so it comes off the end and then goes. The exciting one of that was I was cutting 4130, and I didn't leave enough, and so when the tool was still engaged in the part, it went about that inch and a half with the face and knocked a couple of teeth off, and scared me a little bit. All right, so it put that tool back. So I did something when I watch out when you you know, that escape got me. So I'm going to go ahead and delete that one out. So right clicking, let's see, I think it's on this. No. All right, so I highlighted the 2-inch face mill, and one or more operations, we're going to go ahead and, yes, delete it. This is the tool that I want. And I'll double check going through here that I didn't lose anything else. We have the zigzag, we have the 0, no depths of cut, 0 depth. All right, so we're going to kind of observe what it was doing. I guess I should check and make sure that I change that back. So the loop. And then the linking parameters, the home and reference points we'll get to. So certain machines, if we have a home position for a tool change, we can, if that's written into the post, it will read that value. Tolerances, work coordinate systems and planes, the all-important coolant. Are we doing flood, mist, or through tool? And are they on or off? Additional canned text, miscellaneous values. So the router that I ran had multi heads, and each head could be called as a miscellaneous value. So I could run tools or heads 1 and 2, and those tools would come down and perform. And then the multi-axis, axis control, and rotary axis. So really, except for coolant, we're going to stop at linking parameters. All right. So, but we're going to look down through all these parameters, and then we'll tell it to regenerate. All right. So let's go into the operations. We want to hide show. So continuing on, these are going to be the simulation, the post. Toggle the locking on selected operations. So you don't want them to be adjusted without unlocking. My screen is going to get kind of cluttered, so toggle the display. That turns the toolpath on. It does not delete it. It does not lose it. And then if we ghost it, the little ghost icon there, it's going to say don't post that operation. All right, well, let's go into the next operation. We've established the face. The next one will be a contour. All right, and we're going to pick up the chain. And so the chain is what defines the toolpath. All right, and then we pick onto the geometry. It shows me the direction, and you can kind of see it highlighted in yellow all the way around. Actually, it would be better without the stock being shown, but once we accept. And if we had picked a second chain, there would be multiple chains there that we could pick up the geometry. Out of habit, I prefer to look at the graphic that says my tool is turning this way and I am climb cutting and I am on that side of the part. And if we right click on the chain, then I can change the side. So now I'm cutting the inside of a pocket. Or if we reverse the chain, now I am conventional milling on the outside, and I can visually see that. That makes sense to me. So let's go ahead and reverse the chain again because that was what I wanted. And then when we go ahead and accept, it puts me back into the operation. The tool is still 1. Oh, I lost my 7,500 and 4,000. That should have stayed, or 45 inches a minute. We didn't really go into plunge and retract rates. We can pretty much rapid retract. Plunge rate won't be that aggressive, but it won't be 6 either, so we'll start off with 10. I'm not doing anything with the holders. It picked up the same holder. And then the cut parameters, now the roll cutter around edges sharp versus all that's going to have a little bit more of an effect. Compensation type, starting at the beginning, in the computer is going to adjust to tool center line. Control is going to, at the tool register, if this is a 1/2 inch tool, you're going to enter 0.5. It's also going to have to follow the rules of compensation that say you need the radius of the tool to engage compensation, or for compensation to engage properly. And then if the tool can't move through that arc, it's also going to flash the compensation error that says the tool is too big to cut that arc, just like if we were manually programming at the control. Where is tool center line with a G41 or G42, and then reverse where is the control with compensation. Off says tool center line, and I always have to think about reverse where in the definition. So we can change the compensation direction. So the direction of that arrow is to the left. If I change it to right, it will send it to the interior. But I would prefer to look at that graphic. And if I need to, I'll go back to the toolpath type and edit the chain rather than change the compensation direction. So I pretty much just ignore that one. I kind of understand why that one's there, but not my preference. So try it out, see what it does to your toolpaths, and then you get to pick. Under the contour types, chamfers, ramps, remachining is that tool couldn't get into all the geometry, and we want to identify that material for a smaller tool to come back after it and just machine those areas. And I don't recognize oscillate, so I'm going to have to go back and look at that one. I don't know when they added that. All right, so a depth of cut for 1 inch, 1/2 inch tool, let's go in 1/4 inch. Well, actually, I'm going to tell it to go a little deeper, so max rough step at 260. I don't really need a finish step. All right, so reducing it for that final step, like cleaning up. Keeping the tool down. So does it retract between each step, or does it move to the next level and start again? All right, if you're not sure what that's doing, leave it off. Once you've seen it run a couple times, that is more efficient. Depth by contour, if we were cutting 3 or 4 parts on multiple chains, then do we want to go to full depth of the contour, or do we want to go by depth? So cut the first 1/4 inch, next 1/4 inch, next 1/4 inch, go back, cut to 1/2 inch, 1/2 inch, 1/2 inch. And that can come into, if you have a material with a lot of internal stress, a lot of the stainless, we would want to cut it down evenly to distribute those stresses, rather than take all of it out at one side, and then when we release it out of the vise, it turns into a banana anyway. Let's see, I'm not going to do subprograms, so does it do a macro call? Depth cut direction, step down, step up. Don't remember that one. We'll have to turn that on. Lead-ins we're going to discuss all by themselves later on, and we're running a little long on time, so we'll get these through. Breakthrough would be increasing the depth, so if I use breakthrough, then I'm setting a hard number in the linking parameters. So the breakthrough could be I want to overrun that edge because when we flip it over, we're going to have between 230 and 250 left on the material. I don't want to leave that razor sharp edge. I want to go past by about 10,000, so I believe that's going to be a positive number. Multi-passes are stepping in where depth cuts are stepping down. So if I had a really large boss, I can use the contour to go in. At the same time, the depth cuts are telling it to basically stair step into the material. So multi-passes, no. Tabs were handy for the router where we wanted to leave the last little bit connected so that it didn't throw the part at you. And then linking parameters, let's see, let's go with the 1 inch. Let's stay with the absolutes. Okay, so that one was absolute. 1 inch, 0.2 I'm okay with, and then minus 1 point. All right, and then I'm not going to worry about the coolant at this point. We're just going to go ahead and, oh, what I didn't do, I jumped over it on the cut parameters, stock to leave on walls. This is where I would leave 5/1000ths for our roughing pass. All right, so overlook that when I was focusing on the contour types and the radiuses. So if I leave 5/1000ths on the wall as it's stepping down, that little variation, that little witness mark that it's putting at every level, when I come back with the final contour pass running all the way around the part, that goes back to 0. So we accept it. I don't really like the start point, but that's a lead-in issue. So that also would leave a witness mark right at the midline of the middle of the part. So I don't want to reproduce that whole thing. So we're going to right click and copy. Hopefully. Maybe. Oh, I guess it would help to paste it. Is there, yep, and then paste it. All right, so now I can go in, expand out, double click on the parameters. We turn the depth cuts off. So just as easy as unchecking. And then the, where was the cut parameters, go back to 0. And then we're going to look at the difference between those two operations. All right, so it comes in, goes around. The feed to the next level, instead of full retract, we have enough clearance. I would probably bring that up a little bit tighter so that it's not cutting so much air feeding out. And then let's go ahead. Oh, that one was a dirty operation, so we'll regenerate it. I'm going to highlight. So whatever has the checkbox is what we're acting on. I'm going to turn that display off so that I can see the finish operation come in and go around. Oh, that was isometric. Let's go to the top view. All right, toggle. All right, so we faced, we've run around the outside of the part. We need to do something with the pockets. Let's, I haven't used the that helical bore. So let's see where that one, and we're not ready for the high speed, so, and I'm not seeing it on the right mouse button, so there it is. Hole making helical bore, machining a hole. The nice thing about this is it gives you the description. So machining a hole, using helical motion on a single point, roughing passes. What did it say? Roughing passes are created as you cut down through the hole. All right, select the points and press escape when finished. So we're going to see what we picked. 1 point defined. All right, so let's check out the geometry. 1 and 1. Tool is still the 1-inch tool. We're going to use our stock, and we don't have a model feed position. I can already tell that I'm affecting linking parameters to incremental. I'm going to paint myself into a corner here pretty quick. Stock to leave on walls. We'll go with the 5/1000ths. Let's see, computer compensation. So it is just going to be tool center line, no G41 or G42 on the rough. Start angle at 90 degrees, 180 in. Start at center. We're going to have to see what those do. And then the roughing pitch, 80/1000ths. Feed rate at final depth is 30%, so it's going to slow down when it gets towards the bottom. Helix upward. Okay, not that familiar with this one. And then the linking parameters, we're going to a depth of -1. And I did not see it. It picked the arc geometry. So let me go back and check that real quick as I'm jumping back to the toolpath and the arc geometry. We got the point, but I really want to see it pick that 3/4 inch circle. So let's go ahead and see what it generates. That actually looks pretty good. So we left the material. So I want to pick up the same contour since I did not tell it. Well, let's see if it's available. We have the roughing and the finishing. If I can control it out of the same operation, I will, but I don't really want it to do a helix upward. I could do the circle, which is basically the same as adding another contour and saying, you know, after you get through with the helix, retract, go back in, do the contour pass, and then come up. Finish step over, feed rate, spindle RPM. Well, they bumped that up a little bit, so that kind of makes sense. Well, it's still not bringing my values up. What we'd want to watch for is at 7,500 at 30 inches a minute. I can't really double that, and I sure don't know that I want to double that. So on the rough and the finish, probably stay with the 100% and the 100%, so it doesn't affect the RPMs. All right, that makes it a dirty operation. We regenerate it, and now you can see when it gets to the bottom, it takes one more pass to clean up the wall. Now, I did not see that it turned on compensation, so that would be one that I need to check. So we'll call that one an experiment. If I had more time, we would we go back and add the contour. I want to get into the drilling or we need to get into the pocket operations. All right, so as I rotate, you're seeing those tools engaged into the stock going down. If we see one floating above, that means I left out a minus sign. So the Alt-1. And let's go into a standard pocket. I won't do any more experimenting tonight. We'll go with the chain. All right, so chain is, if it was on the inside, it would be a conventional pass. So I'm the one there waving my finger in the air going, tools rotating this way, and I'm going along the contour this way. That's a climb pass. Well, it's on the interior, so I would still prefer to be climb, so I'm going to reverse the chain. And so, now let's get back in that. So as the tool's spinning and coming around the pocket this way, that is staying in climb. All right, 1/2 inch tool, and because we changed operations, I really didn't expect that one. All right, I'm not going to worry about the rapids, but get in the habit of observing those numbers and putting in hopefully realistic cutting speeds and feeds. Machining direction is climb, pocket type is standard. We have the facing, island facing, remachining, and open. We're going to do standard. Stock to leave on the walls, we'll go with the 5/1000ths. And none on the floor. What happens with the stock to leave on the floor if you have a hard material and it's recutting those chips and putting nice swirls in the bottom of your pocket, then we would want to leave material and come back with a second pocket that isn't producing as big a chip. and do basically a finish pass on the floor. Different types of roughing. Let's just stay with the, well, one thing about the true spiral is it looks neat, but it also generates a ton of code. That's going to be easily a couple 10,000 lines of code generating an XY point for every point on the spiral. High speed's not too bad for the step over. Let's just stay with the standard parallel spiral. So other terminologies would be the for the zigzag would be a lace cut, and then some of these are just how it transitions from one level to the next. Step over percentage at 50%, that's going to be a react. And the entry motion at the helix, we'll leave those for now, and we'll explore all of those parameters a little later. Going back into the finish, one finish pass, cutter compensation at wear. No adjustments to feed rate. And then usually want to start the finish pass at the closest entity, and if I don't have to, I'm not going to retract the tool. There's nothing in that pocket to hit. We're going to leave the tool down, move right over to the start of the lead in, go into the cut. And then same thing with the lead in, lead out for the finishing pass. Now, my preference is to just set up a separate contour so that I have that level of control outside of the pocket routine. But you can do the same types of things in the pocket routine. It just depends on, again, on preference. We're only, what, a 1/4 inch deep? So should be able to take that, not doing anything breakthrough. Let's stay with the absolutes. And I'm not going to adjust that up to 1 inch. The important one is the minus 0.25 on the depth. And then we go ahead and cut it. And so there's our helical ramp in, the step overs, and then our finish pass. And the lead in is pretty big. So the lead in is actually this big arc. We're using every bit of that pocket. And so the lead ins can be reduced down quite a bit. All right, we'll finish up with the drilling, and then in future projects we'll be getting into the tapping, getting into the thread milling, getting into those other operations. All right, so for our drill, we're going to right click, mill toolpaths, drill. This is going to be on entities. We can also filter for various sizes. So if I had a plate with every fractional size, every decimal size, every metric size, we can use the entities, the tolerance to pick common size holes. For 4 holes, I'm going to leave it at select, and the easy is to pick the center point of each of those holes, and it is snapping to that center point. Escape when finished. It tells me what I selected, shows me a preliminary toolpath, and I hit OK. Tool in this case, let me double check, was 4 times 1/4 inch. So we're back into the tool library, and the filter is active, but for the drills, turn the end mill off, and we're going to identify as we come across to the drill. And if you want to go to a specific diameter, you can set additional parameters. Most of the time I don't have the patience. I'm just, okay, there's a 0.25, that's the one I want, let's go. So once I pick it, then same thing, we can go back through and identify diameters, the number of flutes is 2, feed rates, all the defaults, and eventually we might want to write that back to the tool library so that those feeds start staying put. So a high-speed steel at 200 surface feet, 3056, 5 thousandths per tooth chip load. That's a little heavy. Probably wouldn't run it that hard, at least initially. We'll try to keep it under 20. So, and then when you see decimal places out to 3 places, 18 is good. Even the 56 annoys me a little bit. So probably either change it to 3000 even, 3100 even, 3050, whatever. All right, so the stock, well, we have the same stock. So this is new in 2017, 2018. So I don't think we need to set that up. The cut parameters, this is where we're going to pick drill, counterbore, pec drill, chip break, tap, all of the boring, all the other cycle types. So drill is going to be G81. The counterbore is when we set the dwell. Pec drill is going to be our G80. G83.
It'll be 83 if it.
And then the chip break is G73. And then the tap G84. So I'm juggling numbers in my head all of a sudden. So drill is, wow, we're really trusting this. We have a parabolic. We're going to jam it straight through the part without a center drill. Not likely. All right, if we're going to forego the center drill, then we're going to pec drill. We'll go by materials. So if we just did half D, I might try half the diameter, 125. All right, so that shouldn't be too far out of the realm of possibility. A lot of times I'll increase that feed rate. If I was running at 30, I might drop that down to 60 or 30 thousandths per peck and increase the feed rate. Problem is that it goes in, it comes out, it goes in, it comes out. It's making that trip every time. And if we could get away with the high speed, the G73 chip break, then it's only retracting about 5 or 10 thousandths. For a production environment, we want to get that drill through the material as quick as possible. All right, so linking parameters, top of stock. If we need additional clearance, just keep in mind that it's impressive. First time through, we're probably going to override the control to 25% and watch it come down a little slower. But it's always impressive watching that drill diving towards the top of the part at rapid and stopping 100 thousandths above the part and then starting its peck. So not for the faint of heart. Minus 1 inch on the depth. You have a little calculator here that you can calculate the drill tip, but we also have tip comp. And I would prefer to stay with tip comp. So tip comp says there's a breakthrough amount of 10 thousandths. Calculated on the 1/4 inch that the tip length is 75 thousandths and the tip angle 118. I would rather you leave the 118 and put 135 in there than not go all the way through. All right, the other thing is this isn't going through the whole 1 1/4 inch of material. We're counting that when I flip that over and face off the backside, then we'll pick that, those holes will magically appear. All right, so we're not going to do the face operation on the backside tonight since this has run a little bit long. We do want to be able to do the simulation though, so I'm highlighting so that all of the folders are checked. When you go to the Toolpath group, it grabs everything. And then you're going to turn on the display, turn off the display, turn on the display, so we can see what's going on. Our 2 simulations then are backplot. One of the tutorials says turn the backplot on off. They don't want you using it all. I think it's still handy. I like the visual of the standard wireframe backplot. So when we click it and hit play, you know, it's very simplified. You know, nothing fancy, but it gives me a real quick visual without doing anything extra. Okay, and then the graphics display. If we do the verify, and then there's also options which we'll look at later. Then the solid graphics, when it runs, launches this external window, and we see it. So what we'd be looking for here are those. Wow, it rapid through the wall of the part, made a nice gouge, did something completely stupid that I told it to do. And you know, now's our chance to catch it. All right, so on the demo versions at home, you're not going to be able to post. Here we should be able to G1, do the post-processing. It's going to put a .nc extension, and I'll go ahead and put this on my external. And did I ever, oh yeah, we did save this. I haven't caught up to the save. So the code expert, which is Mastercam's editor and is a pretty decent editor, comes up. This is the code that it's producing for the default. Dates, times, tools, and then it goes into the code. And the Helix, yeah, the Helix got a little bit long there, but that takes us through the mix. The one I would watch out for that jumps out is this thinks it's got a fourth axis. Anytime you see an A and there's not an A, guaranteed that program's not gonna run. All right, so unless I have a fourth axis rotary that A position actually does a call, where we need to pick a different post processor.
You set an incremental step for the helical moves. Will then it just provide a loop?
Typically, the incremental is telling it to start or stop in relation to the wireframe, so that you're not stopping the rapid at the 1 inch above. I can wrap it all the way into that pocket if I set an incremental move that says it's 100 thousandths off the bottom of that pocket.
So,
but I'm responsible for making sure that material is gone when it rapids.
True, but when you're doing the helical interpolation, you're generating a lot of lines of code.
Right.
I think you could just generate one and say loop it, 10
Well, it depends on the pitch. And we're not telling it to do subprograms or loops at this point. So
you do have the ability to.
You can, I think you can do the subprogram, but at the other end of that is, since if the length of the program, I have my control's older. It has 1 meg of
Yes,
RAM.
that's what I'm getting at.
All right, that is not going to be anywhere near 1 meg. 1 meg is my 3-axis program that's going to run for the next 6 hours. And then when it goes to 1.1 meg, I got to go over to the laptop and start DNCing it, doing the direct numerical control and trickle feed it so that it finishes out the 1,000,000 lines of code. This program, if we go chase it down, is probably less than it's 8K. So even though it's writing all of that extra lines of code, I trust it for the most part. I'm going to, back to that trust but verify is we're going to run it slow, we're going to watch it engage, we're going to observe and react, but I'm not going to do anything to try and shorten that unless it's an issue. The router that I mentioned had 40 kilobytes of memory. So when we ran 100 some odd little widgets on it, it had to have subroutines, it had to have subprograms to, and incremental moves to step over, and it still filled the control. So you're always trying to make that adjustment. All right, so this will take you through the first assignment. Feel free to fast forward through the long parts. This went a little bit longer than I intended, so we'll see how these go. We may get to the second or third assignment, and I will provide you a DWG, or I'll provide you something so that we're spending more time. But I do want you to have the ability to go in, make the adjustments with the drawing, understand the drawing tools, not be tripped up and have to go back to SolidWorks or AutoCAD or Inventor or whatever and re-output translation file because you needed a line somewhere. All right, be able to do it inside of this program and make it work.